Hey everyone, I guess I'm a few minutes early, so I'll just wait here until I get a heads up that someone is watching. But yeah, basically this video is going to be a review for your science exam, which hopefully you remember is next Monday. I'll just put some information here while I'm waiting for you, and then at 9:50 or 9:55 or so, we will get started. Okay. Yeah, so your exam is going to be 50 multiple choice questions, and that's it. All right, so there might be like I haven't written up the exam yet, but there might be things like diagrams, perhaps diagram of a cell, things like that, where I then ask you a multiple choice question on it. So the things that we did with diagrams, I won't have you draw anything. It'll either be, I have a diagram and I ask you, what's wrong with this diagram or what's correct about this diagram, or identify something, or I'll ask you a question like perhaps for chemistry, what's the correct or the most correct diagram for chlorine, and I'll give you 4 options, and you have to pick the right option. But I'll figure that out. But yeah, you're just going to be responsible for bubbling in the right answer. Yeah, aside from that, there's not much else to it. It'll be 50 multiple choice questions, and I will elaborate on that once I can see that somebody is here watching. Let's set this up a little bit better. Something like that. Okay, cool. Perhaps it would have been easier for me to do this somewhere with a bigger board and more board space, but that's okay. I think this is probably the best option. 9:48, so you guys are probably still in your first class. So I'll give this a few more minutes and then we'll break down the exam one more time. I've got the review video, the breakdown video in front of me as well. So we won't waste too much time going over things that aren't on the exam if they're not going to be there. but we'll go into detail. I can give you examples of questions and stuff for the things that are there. And if there's something that you don't understand, then we can talk about that. The exception to it would be with biology, when it comes to organelles and their functions, it would just take so much time to draw the cell to talk about one of them that it would probably be better to review review your notes and let me know about that. But we'll figure that out. Okay. It's 9:50, so you guys should be almost there, I guess, at this point. But yeah, so I was saying that for biology, we'll go over the organelles and their functions. We talked about it in your notes. I won't test you too much on biology, so don't stress too much about it. But for the rest of the units, like chemistry with bonding and stuff, it got a little bit more confusing. So we can go over the other 4 units in more detail. Biology, just don't stress too much about it. There aren't going to be very many questions on it. All right, once you guys get here, we will start the live stream. I just don't know how much longer that's going to be, but that's all right. I got time. Yes, so this live stream is going to last from the start of period 2 straight through break and go to the end of period 3. You don't have to stay through break. It's, I think, just easier if the entire review is all kind of together. Maybe it's not. If you guys all disperse during break, then I can break it off into 2 chunks. But my plan as of right now is to make it one long, kind of hour and a half long video for you guys. So we'll see how that goes. Breakdown, yes, 50 multiple choice questions. And yes, there will be a significant focus on astronomy and probably also geology. I haven't, like I said, I haven't written up the whole exam yet, so I'm not positive on that. But because we haven't had a test on astronomy, there'll be more focus on astronomy. Okay, so if you find that information useful, then study your astronomy unit, which is basically almost entirely on YouTube. So that works out for you. And for those of you with the math exam, remember that that is this week, Wednesday and Thursday. But I believe those of you with the math exam are coming onto this a little bit later, at least most of you. Yeah, so when you guys get here, if you have your questions, obviously you can hear me, but I can't hear you. So if you could add your questions to the sort of the live chat thing that goes on with this, then put those just put all the questions that come up over there so that I can sort of refer to that as we go. Just so that I know what exactly you guys want to review. I don't want to sit here blabbing on about physics for 25 minutes when you guys all have questions on chemistry or geology or something. So yeah, so any specific questions, your questions can be as specific as you like, as broad as you like. Either option is fine. But yeah, basically, these 5 topics will all be covered on the exam. I just don't know exactly the split. Once I've written the exam, I can send a breakdown. If it's before the end of the week, I'll send sort of a rough breakdown of, 10 of the questions are on biology, but 25 are on astronomy. Like, I'll give that kind of a breakdown later on in the week once I'm done the exam. All right, looks like you guys are about to get this set up on your end, so we should be good to start shortly. I'm just waiting until I see the little icon for viewers tick from 0 to 1, and then we'll get going. Yeah, so basically, like I was saying, I mean, I'm just kind of blabbing right now, but yeah, these 5 topics will all be covered. More focus on astronomy, more focus on geology, maybe more focus, well, not really more focus on physics, because I'm not testing you on very much from physics, because you guys did understand the physics test. But the thing is, on the units, in the units where you guys did well and understood stuff, like, for example, physics, if I put more questions for that unit, that's a mark booster for you guys. All right, you guys have ticked from 0 to 1 viewers, which means hopefully you guys can see what's going on. So, yeah, I've just been blabbing to myself for the last 10 minutes. Don't mind me. But yeah, so the science exam is next Monday. It's 50 multiple choice questions. I think we've sort of touched on this before, and it'll be on all 5 units that we covered from September to May. If you have any specific questions, can you add them to like the chat window that comes with the live stream? Because you guys can see me, but I can't see you. So I have no idea if there's anything specific that you guys want to cover, or if you know, it can be specific, it can be vague. If you want to like go over a specific concept, then I'll do that. If you want to go over like what are you going to test in chemistry or something, then I'll give examples of that stuff. But yeah, so any questions, if you can just type them in so that I know exactly what you want to cover. Otherwise, we'll just sort of go through a breakdown of each unit. There is a breakdown video already, but I've got a little bit of a better idea of how I want to do this now. Yeah, basically, so the biology unit won't have very much focus. I'll just make this like a small dot or something. So not much focus on biology. There will be a significant amount on chemistry and physics, and then there'll be more on geology and astronomy. So here's my reasoning for it. You guys did pretty well in chemistry and physics, so if I test you on it, that should hopefully be a bit of a mark booster rather than a test. It's kind of more like free marks. Not every question, but some of the questions, because you guys as a class did so well, I feel like most of you would find several of the questions fairly straightforward, which is just me handing out marks to you on the test. Biology, you guys did well, but we did it so long ago and haven't reviewed it properly since then that I don't want to test it super thoroughly, just because you forget stuff over the course of 8-9 months. I with my courses here, I forgot stuff over the course of 8 months. I forgot stuff over the course of 3 months, for crying out loud. So biology won't be very in depth on the exam. Later on in the week, I'll have a better idea of a breakdown, because I haven't finished writing the exam yet. I'll have a better idea of, out of these 50 questions, how many are on biology. So you guys can sort of get an idea of how much you should be studying for each of these. But I can tell you for sure study astronomy because we haven't had a test on it yet. So the main focus of the exam will be astronomy. Not main focus like 2/3 of the exam, but like if there's 50 questions, then instead of 10 questions for each subject, it could be 20 for astronomy or something like that. So a little bit more focus on astronomy, also a little bit more focus on geology because the first geology test didn't go so well. So I feel like because it was our weakest point this school year, that I'm giving you another opportunity to show that you have sort of retained what you learned for the second geology test. So there'll be a little bit of an extra focus on geology. I'm not going to make any section deliberately difficult per se, but there's just going to be more emphasis on astronomy and geology. But I'll just kind of walk you through the breakdown one more time, and then if you come up with any questions, just let me know, and then we can break that down. So biology, there was only one thing that I wanted us to sort of remember for the final, and that was what the different organelles are. So if you've forgotten what that word is, think organ, and it's just kind of the cell's version of organ. So the main components of a cell that do all the main jobs of a cell, like for example the nucleus and the cell membrane and the cytoplasm. They all have these important jobs in the cell. So I want you to know what the organelles are, and I want you to know what they do. Now, here's the thing. If you studied, I feel like at least with the flamingos, I feel like we did something like 13 organelles, but I don't think it was particularly different for the parrots. So my thinking is, if we did 13 organelles, I'm not going to test you. I'm not going to have 13 multiple choice questions on what does this do? What does that do? What is a ribosome and what is the nucleus? And I'm not going to make a single question for all of them. But what I'll do instead is I'll sort of pick 6 or 7 of them. For the flamingos, maybe I'll pick a little bit more, and 8 to 10, something like that. But I won't ask you all of them. And the reason is twofold. The first part is that we haven't talked about this in so long that it's easy to forget stuff, but also it's a testing situation. Even if we talked about it yesterday, if you get stressed out in a test, your brain sort of starts to shut down, and it's unreasonable of me to expect you to remember all 13. I can expect you to remember most, but it's not fair of me to ask you to remember all of them. You know, it's like if we did, if we talked about 7 different types of relative dating in geology, it's not fair for me to ask you about all 7. I'll ask you for 3 or 4 or maybe 5, but you know, just that kind of thing. So for biology, know the organelles, just know what their names are and know what their functions are. If you want, I don't think I'll put a diagram of a cell, just because a lot of diagrams of the cell can be really hard to see when they're printed out and made this big. Whoops. When they're printed out and made kind of this big on a sheet of paper, and then you're trying to figure out what 13 different things in that image are supposed to represent. So I won't test you by putting a diagram and saying, you know, label these, or putting a diagram and circling one and saying, what is this? I don't like to do it that way. So, but what I will suggest is that you do look at the diagrams of the cell that we drew or that we looked at before. If you can't find any in your notes, just Google, you know, cross section of a plant cell or diagram of an animal cell, things like that. Just because it can give you a better idea of what they do based on kind of where they are in the cell. For example, if you forget the difference between cell wall and cell membrane or something, if you can look at a diagram of a plant cell and realize, oh, the cell wall is on the outside and the membrane is on the inside, then that can sort of help give you a context for on the test. If I ask you, what does the cell wall do, then maybe you can reason your way to the answer. If you don't remember it already, you can reason your way to the answer by saying, oh, the cell wall is on the outside, therefore this must be the case. So things like that. So just know the organelles and their functions. That's kind of it for biology. Like I said, I haven't written the exam out yet, but it's not going to be 10 questions per unit. It'll be probably something like 7. I don't know for sure, but it'll probably be something like 7 questions on, seven different organelles or functions. So I can ask you, I give you an organelle, and your options are to tell me what they do, or I give you a function and you tell me which organelle performs this function. Okay, so those are the two kind of main possibilities for the biology exam, or the biology section of the exam. Now, chemistry, we did talk about a little bit more. So there are two things that I could sort of test you on. And the first thing is diagrams of atoms. So diagrams they're called Bohr diagrams, but it's like the so basically what I'm talking about is that when you have like nitrogen, you have the N in the middle, and you can have the N in a circle in the middle if you wish, and then you have your dotted orbitals going around, and then you put your electrons on 1, 2, 3, 4, 5, 6, 7. So something like that. So I won't ask you to draw the atom, but I will ask you that, if I've drawn it like this, is this correct? Is this a correct drawing for nitrogen? So you can check that in a couple of ways. You can check that the number of electrons is right. You can check that they're in the right spot, because remember that the innermost orbital must be full before you can move to the next one. So if I drew it like this, for instance, it still has 7 electrons, but I haven't followed the rule for filling the innermost orbital first, right? So, so things like that. If I give you this diagram and I say, what's wrong with this diagram? Because if I say, is this diagram, correct? Have I drawn it correctly? Your only options are yes and no. But if I say, what's wrong with this diagram, then you could say, oh, well, the number of electrons is wrong. The organization of the electrons is wrong, or something, right? So there are more ways that you can go wrong with these diagrams, especially for bigger and bigger atoms. Also remember with these diagrams that when you're pairing up the electrons, it never goes to more than 2. So if I drew it like 1, 2, 3, 4, 5, 6, 7, if I drew it like that, that's just extremely wrong, because you never have 3 electrons like this in the diagrams that we talked about. They're only ever in pairs. So that's the first thing, is going to be drawing atoms. Or so like I'll have a diagram of an atom and ask you, what element is this? If I take this out and I've drawn it all correctly, then I can say, what element is this? Or I could ask it without a diagram, which atom has 7 electrons, which element has 7 electrons, and then you need to be able to figure out that it's nitrogen. So for that, it might be a good idea, perhaps not to memorize, but to be familiar with the first 10 to 20 elements of the periodic table. If I can find a sort of printer-friendly diagram of the periodic table, I will include it on the exam. Otherwise, I can have whoever the teacher is going to be on the day of your exam, which is next Monday. You guys can figure that out, but whoever is with the class on the day of the exam can just pull up a periodic table on the computer or something, if that's easier. But yeah, so make sure you gain some familiarity with the different elements of the periodic table, and when do you jump from the first orbital to the second, from the second to the third, and so on. The second thing with chemistry that we talked about was bonding. I'm getting rid of this because I don't like that. The second thing that we talked about was bonding. So let's say we have like a fluorine atom here. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9. And I'm actually going to move that one over there. Okay, so we've got our 9 atoms, or 9 electrons of fluorine. And then you've got something like sodium here, or for the sake of simplicity, we'll say lithium over here. So you need to be able to probably it's harder kind of to describe the bonding with a diagram in a way that makes sense on the exam. So what I might just do is use words for these ones, but you're welcome to use diagrams to sort of work out if it's ionic or covalent. But so you could draw out your atoms, or I might perhaps for a question draw out an atom for you, or a pair of atoms like this, and I'll say, what happens? Is it an ionic bond where one atom donates its electrons to the other, or is it a covalent bond where they choose to share? And now if I draw a diagram for you and I do this, remember that this means it's ionic. That means that the lithium atom is donating its electron to fluorine. But if it was a different case and it was a covalent bond, you would see sort of a bubble around two electrons, saying that lithium and fluorine are sharing it. Now, they don't, because if you look through your notes, lithium is a metal, fluorine is a non-metal, and those bonds are always ionic. But yeah, so just know that if you're sort of trying to work it out, the bubbles are for covalent bonds and the arrows are for ionic bonds, that the electron is being donated from one atom to the other. And that's kind of it for chemistry. There's not much more to it than that, because I don't want to test you too much on it, since you guys, once again, it was a unit that we did a long time ago, and you guys did fairly well on it. So I will test you enough on it because I'm confident that you guys will get lots of marks for that section, but I won't test you too much because we did it a long time ago. So that's chemistry there, and that's also chemistry down there. All right, geology was our next unit, and I've listed 4 things that you should know. The first one is classification of rocks. Maybe I'll just put rock classification like that. So you should know the classification of rocks. So what that means is you should be familiar with the rock cycle. You don't have to memorize and fill out the rock cycle anywhere, but you should be familiar with it in that you should understand how each type of rock forms. That, you know, if you have sediments that all compress and cement together to form a rock, what type of rock is that? You need to be able to figure that out. And if you look at the rock cycle, especially the color-coded rock cycle, you can see that a certain type of rock, doesn't matter where it's coming from, as long as the process is the same, melting and cooling, or, you know, tremendous heat and pressure, all of that stuff. As long as the process of the formation of the rock is the same, the type of rock that the original rock was doesn't matter. The new rock depends entirely on the formation process. So if you look at it, all igneous rocks have the same color arrow pointing to it, saying that this is the process that makes an igneous rock. And then it was the same thing for sedimentary and metamorphic. So you should know those types of rocks. And it's good to know, kind of, if you're looking at the rock cycle, it's good to know where, you know, sediments and magma and things like that sort of fit into the system. But it's fine if you just kind of learn about the 3 types of rocks, because that's all I'm really going to ask you on for that. The next thing you need to know is plate tectonics. So I'm not saying like look at a map and memorize, you know, everything, all the plate boundaries in the world or anything like that. But you should know kind of the different types of faults. So you should know, you know, what's the difference between a convergent boundary and a divergent boundary, or what does it look like? You know, at a convergent boundary, is there a mountain? Is there a valley? Possibly both. Something else? Those are the things that you should be familiar with. That I mean, I won't like put a picture of a boundary and say what type of boundary is this, but you should know what they are, kind of like as a concept, that convergent is 2 plates moving together, and then you should also know them by kind of how they look. That if you have, like, for example, the Indian subcontinent and the rest of Asia, and you've got a really tall mountain range in the middle, and I ask you, is this convergent or divergent? You need to remember, okay, divergent boundaries never formed mountains. there was like the new magma at the sea floor and all of that stuff, but convergent boundaries could form mountains. So between the two, you can make a guess at one of them if you're not sure. Also, if you have no idea what I'm talking about and you never drew these diagrams, for anything that we did after like October, so basically anything after the biology unit and half the chemistry unit. So the tail end of the chemistry unit, sort of the chemistry review stuff, and then geology, physics, astronomy, I still have all the notes on that stuff. For biology, it was all handwritten stuff that we did in class, so I don't have as comprehensive a record of it. But geology, physics, and astronomy, I can send you the very PowerPoints that we used in class, so that you know that you're looking at the same diagram that we talked about before. So you can just send me an email or something for that. If you have sent me an email and haven't gotten a reply in the last day or whatever, try sending it again. I've been sort of fiddling around with email stuff, getting things sort of set up. It's just with technology. So, me with technology it's not fantastic. So, yeah, so there's a chance that if you sent me an email, I either missed the email or just missed the notification for it, so I haven't checked it yet. But you can send me an email wherever, or if it's easier, you can sort of leave a comment on this video or something. I'll be checking YouTube hopefully very much over the course of the next week for your guys's questions and comments and stuff like that. So for geology, that's 2 of the 4 main things. The third thing we talked about in geology was geologic time. So that was like the eons and the eras and all of that stuff. You don't need to know them all in order, but you should know, kind of some of the major events from some of them. Like, for example, the asteroid impact that killed the dinosaurs happened in which era, or like it was the boundary between which 2 eras, or what era did the dinosaurs live in? You should know those kinds of things. What era are we living in? These kinds of questions I might ask you about for geologic time. So you should understand how all of those things work together. If I ask you which is longer, or if I give you a question saying which of these is the longest periods of geologic time, and I give you era, eon, age, and I don't know, period, something like that, then you should be able to figure out which one is the longest, which one is the shortest. Or I list 4 eons in different order, and I say which order has them going from longest period of time to shortest period of time, like super eon, era, etc. Or I could say which organization of them is going chronologically, so in order of longest ago to most recent, furthest in the past to most recent. So like like a Mesozoic before the Cenozoic era, or Cenozoic before the Mesozoic era. You need to be able to tell the difference between those 2. So there aren't that many different types of questions that I can ask for each of these things, but collectively that it makes for a fairly comprehensive geology unit. And there's still one more thing, which was relative dating, which you guys found very funny in class. Incidentally, that reminds me, there will be no Dwayne Johnson on your exam, unfortunately. I might put him here or there in a question, but there won't be any pictures. But yeah, the last thing for geology is relative dating. So we talked about a whole different, we just talked about a variety of relative dating techniques, with superposition, that you have the oldest rock, then the next one, then the youngest one up here, or you have a rock that's then been cut by something, and the cut must have come after the rock, because otherwise there would have been nothing to cut. So like the principles of relative dating, we talked about like 7 or 8 of them. They're not that hard to sort of understand. It's just sort of linking the name to the process, I think, was more of the problem. Because, for example, that really long one that none of you liked remembering, uniformitarianism. It's just, you have to match the name to the definition, know what they are. If I give you a picture of A, B, C, kind of in like a rock A here, rock B here, rock C here, then I say which rock is the oldest, you need to be able to figure that out, right? And they'll all still be given in the context of multiple choice questions. So if you see a concept here that you think there won't be very much on it in the way of multiple choice questions, then maybe devote some of your time elsewhere, because there aren't that many ways that I can ask you about, for example, about plate tectonics. There are a few different types of questions I can ask, but to keep it in the form of multiple choice, it restricts my options a little bit. All right, so those are the 4 points for geology. I'm seeing no specific or general questions, so I'll just keep going. Physics, there were only 2 things that we sort of talked about. The first, there are only 2 things that we're going to be testing on. So the first is Newton's laws. So you should know what Newton's three laws are and sort of where they come into play in our daily lives. So if I ask you which one of these definitions is a definition of the first law, then I'll just write out the definitions of the 3 laws, and you need to be able to identify which one is the first law of motion. But what if I gave you a question like, a ball is rolling on the ground and it never stops, or something like that? It's sliding on ice, and it just keeps going forever until it hits a wall. It's like a puck on an ice rink or something. And then I ask you which law is at play. So you need to know the definition, but you need to understand the definition. It doesn't help for you to know, oh, F equals ma, but then I ask you, what's F? And you go, I don't know, football. No, like you need to understand the definition and know the actual definition kind of in words so that you can recognize it in a question. And the second thing that I'll test you on from our physics unit is energy. And the only reason I'm doing this is because you guys seem to understand the energy concept quite well. It won't be very math heavy. It'll be more of a conceptual thing. Like if I release a ball from rest, does it have any kinetic energy at the beginning? Things like that. It's a concept, not calculate the speed at which it hits the ground, which you could do, but you won't have to do. So those are the 2 things for physics. If you have any questions about either of those, let me know. And then the last thing we talked about was astronomy. And there are 4 things that I listed in your breakdown that you should know for astronomy. I'm sort of running out of room, but I'm good for now. So the first thing is facts about the planets. So facts about the planets in the sense of, you don't have to memorize like all of their axial tilts and stuff, but you should have a reasonably good idea for things like, if I ask you which planet is the biggest, order these planets from closest to the sun to farthest from the sun. You should have that familiarity with the solar system, that if I list, Saturn, Venus, Neptune, Mars, and then I rewrite it 4 different ways, and then I say which one of these orders the planets from closest to the sun to farthest from the sun, or from smallest to largest, you should know those things. So you should know the planets in order from first to last in terms of distance, and you should know them in order of biggest to smallest, and maybe a couple of qualities here and there about some of them. You don't need to know qualities about all of them, but for example, which planet has the biggest and brightest rings is an easy one. But something like which planet has a great red spot, a storm that's bigger than Earth, that's maybe not. I thought it was common knowledge when I was younger, but I learned fairly quickly that not everybody knows that. So those kinds of things you should study. You should know those. What makes a certain planet different from the rest? What has captured scientists' interest about certain planets? For example, Venus, it could be its atmosphere. Jupiter could be its great red spot. Neptune could be its great dark spot. Uranus, its axial tilt, the fact that it rotates all the way over on its side and it sort of rolls rather than spins. So that's the kind of stuff that you should know about the planets. You should know the life cycle and also the death of stars. I don't know if I clarified this in a previous video. I think I did, but one of you asked if massive stars can become white dwarfs, and the answer I'd originally said was yes, because I didn't read the message carefully enough. But the answer is no. White dwarfs are for stars that are sort of the mass of our sun, but for stars that are way, way, way more massive, they generally become neutron stars or sometimes black holes. And then and then it gets more complicated with supermassive black holes and quasars and all of these things. These things get more and more complicated. So don't worry about that. But you should understand the life cycle of a star. So you should understand that it begins with this nebula, this sort of cloud of gas and dust and debris and those kinds of things, forms into a star. You should understand what the word fusion is. We sort of talked about it. And then you should know, as it's approaching the end of its life, what happens. What is a black hole? What is what is the core collapse that causes a supernova? You should know what the word supernova is. So things like that. You should know the terminology used when we're talking about the life and death of stars. The next thing was phases of the moon. I realize I'm not writing this in any sort of detail, but you guys can hear what I'm saying. So so planets, stars, the moon, phases of the moon. So you don't have to know anything. Maybe it'll be a bonus question or something like the orbit length of the moon. But you should know the phases. So you should know, if I put a picture of a crescent moon, you should know that it is indeed a crescent. I won't ask questions like, is it a waxing crescent or a waning crescent? Because it's just one. In one, the right half of the moon is illuminated, and in the other, the left half of the moon is illuminated. So it's not fair for me to say, is this first quarter or last quarter? Or is this a waxing gibbous or a waning gibbous? But you should know the words crescent and gibbous for sure. And then first and last quarter, I probably won't test you very much on. But you should know the phases of the moon. So that maybe if I said, starting from a new moon, which one comes first out of the following ones? And I put waxing gibbous, full moon, waning crescent, and first quarter or something. You need to be able to figure out the order of those. All right, so that's one more thing you should study. And the last thing for astronomy, this is just, I think we're lining up very nicely with your break. The last thing for astronomy was exoplanets. There won't be too much that I ask you about exoplanets specifically, just because it does get a little bit advanced. But I will ask you things like, what they are, different types of them. We talked about sort of super Earths, and we talked about hot Jupiters. I can ask you to name a type, and I'll make up 3 names and put 1 real name or something. I can ask you about how we detect them. But once again, because it has to be in the context of a multiple choice question, I'm a little bit limited in that. But I can still ask you how exoplanets are detected. And maybe I sort of give you a blurb to remind you what one of the techniques is, but then I ask you a question about that blurb, that, why does transit photometry favor planets with shorter orbits or something like that? So those kinds of things, you can go back and rewatch all the astronomy videos, of course, if you want to, for that stuff. I'm going to try to make sure that the astronomy section is not too hard. My shortcoming is that I can kind of get carried away with subjects that I enjoy, and astronomy by a long shot wins for subjects I enjoy out of this. So yeah, for astronomy, I'll try not to make it too hard, but no promises. I'm gonna do my best. So it should hopefully be fairly easy. And the exam's difficulty as a whole, I'm actually gonna make it the same test paper for the parrots and for the flamingos. So I'm gonna aim for it to be something that's sort of in between the 2 levels. Not that every question is going to be a little bit tough for the flamingos, or a little bit tough for the parrots and a little bit easy for the flamingos, but I'll have some questions that are kind of more at the parrots level, you guys are at a fairly similar level in science class. Our lessons that we did in class, I did the exact same PowerPoint for both classes. You guys gained the same amount of information, but I just, on your tests, on your respective tests, I asked less of the parrots. But yeah, so I might have some questions that are more at the parrots level, in that I'm asking a little bit less than I would normally ask the flamingos. So for example, if it's geologic time, I might give you 3 time periods, whereas if it was just the flamingos, I might give them 4 time periods, something like that. If I'm doing organelles, I might do 6 or 7 organelles, whereas for the flamingos, I might have done 9 or 10 organelles. So things like that. Some of those things will be a little bit more at the parrots level, so the flamingos should hopefully find it a little bit easy. But then there will be some sections, because I'm testing the flamingos as well, some sections will be more at the flamingos level, and parrots, just give it your best shot. So yeah, so that's basically the exam review. If my clock is right, then you guys are good to go for break. If any of you have questions, let somebody know so that they can let me know. Let one of your teachers know so that they can inform me, and then I can clarify. I will leave tomorrow's science class as a review session, and flamingos, if and when you're there. If you have any questions for the math exam, you can ask those during the science exam review as well. But other than that, parrots, which I believe it's the parrots right now. Hopefully I'm right in saying that. If it is the parrots right now, you guys are good to go for break. And I will sort of just stick around through break in case anybody has questions in this time. But otherwise, we'll just pick up in 15 minutes. Or 20 minutes, you know, something like that. Right, I'm seeing no questions, so I presume we'll just start in 15 minutes. But we'll see. The test, yes, the test is only going to be multiple choice questions. It's 50 multiple choice, and that's it. Nothing else. No diagrams, no nothing. If there are diagrams, I will have drawn the diagrams, and your question will be a multiple choice question. Yes. Perfect. Thank you. I think this, I hope this system of the questions is working for you guys. But yeah, any other questions, just let me know. The math exam will not be only multiple choice. There'll be a little bit, but the science exam is entirely multiple choice. Yes. All right. That clock is off. I think this clock is right. Okay, cool. Yeah. Okay, so I'll just sit here and wait, and we'll pick up at, I guess I'll be ready at 10:45. I know sometimes the break goes a little bit longer, so if it happens to extend up until 10:47 or 10:50, that's fine, but I'll wait until the viewer count ticks back up to 1. th is the 22nd. All right. Cool. Hopefully that's big enough. I have no idea what's going on. Okay, yeah, this will have to do. Science breakdown. All right, let me pull up. I'll pull up the math breakdown just in case flamingos find it useful. Okay, so when the flamingos are here, I have both the science and math review videos, depending on what they want. Right. 10:47. Science exam review, math exam stuff. Okay. Good. All set. I don't know if that helps at all. All right. Okie doke. So, just kind of blab for a minute or two before we start. But just a reminder for you guys, flamingos, your math exam is this Wednesday and Thursday. So if you have any math questions at this time, then feel free to ask and we can go through some of those. But otherwise, I'm going to go through the science exam review in this live stream. And if you guys have any general questions about any of the units, about the way the exam is going to work, time and all of that, then leave that in the chat window on the side. Yeah, so that I can see it, because obviously you guys can see me, I can't see you. So if you have any of those questions, general or specific, have them left in the chat window on the side so that I know what you guys want me to focus on, because I don't want to be sitting here just kind of blabbing about physics if you guys all have questions about geology or biology or something. So if there are any questions, then leave them there and we'll talk about those things. But otherwise, I'm basically going to go through the same sort of review that we went through in the breakdown video of each unit and what you'll be expected to know. But the other thing is, just want to sort of remind you, the exam is 50 multiple choice questions, and yes, it is all multiple choice. So the science exam is all multiple choice. The math exam, we will talk about another time. If you guys want another review session, I can do one this coming weekend. It'll be a bit of a time crunch, but I can do 1 or 2 videos in this, at the end of this week, but nothing before that, I don't think. Just because the thing is, I'm free for much of the day, especially on Wednesdays and Fridays, but I'm almost always busy when you guys have school. The reason I'm able to do this today is because it's a holiday here. So yeah, if you have any questions for math and you would like a whole separate review session for that, I can potentially do on Friday. Otherwise, we could figure something out over the weekend, a specific time over the weekend. But otherwise, we'll just go through the science review, and if any questions come up as I'm going through it, just leave them there and I will answer them. So the science exam, 50 multiple choice questions, and it is next Monday. What am I saying for the math review? I can't do it next weekend. The math review is over. Ignore all of that, what I said. If you want another science exam review on the weekend, that will work. But your math exam is this week, so hopefully you guys are prepared for that. I just sort of lost track of where I was in the calendar. But yeah, your science exam will be this Wednesday and Thursday, and your science exam is next Monday. So if you want a science exam review over the weekend, if this isn't enough, then let me know. But yeah, so we'll just go through each unit. Right off the bat, I want to highlight the importance of the geology and astronomy units, just because kind of as a collective flamingos and parrots class, the geology test didn't go very well. So I'm going to focus on it a little bit extra. And the astronomy unit, we haven't had a test yet, so I'm going to focus on it a little bit extra as well. And on the opposite side of the spectrum, biology is not going to have very much focus on it at all. And the reason for that is that, one, you guys did well in the biology unit. You guys were understanding stuff, so I'm confident that you know what we learned. But the other thing is that I also understand the fact that you may have forgotten a good chunk of it because you haven't we haven't talked about it since like September, or well, since early to mid-October, which is a really long time to go without reviewing something. So I understand that the biology side of it might be a little bit shaky, so I won't test you too much on that, just because I don't want it to be something that brings your mark down. And there will be a reasonable amount on chemistry and physics, kind of in between the amount for biology, but less, so more than biology, but less than geology and astronomy. And the reason for that is you guys did well on both of those. So I'm hoping that some of the questions will be a little bit of a mark booster, that it'll sort of be like free marks for you guys. But some of them might be a little bit more challenging. We'll see. And also the level of the exam, so like the level of difficulty of the exam is going to generally be somewhere in between where the parrots are and where the flamingos are. So for some questions, so like on your past tests, if we were talking about relative dating in geology or something, we talked about 8 techniques and I asked you to describe 3 or 4 of them, I would only have asked the parrots to describe like 2 of them. So for biology, if we did like a dozen organelles, I have the number 13 in my head, that we did 13 organelles, where I would normally have asked the parrots for like 6 or 7. I might have asked you for more like 8 or 9 or 10. So some of the questions will be more at the parrots level in that I'll ask for a little bit less than you might be expecting. And then other questions will be more at your level that I'm asking a lot of the parrots because I'm bringing it up to your level. So for biology, we'll just get into the breakdown of each unit, and then if you have any questions, let me know. But so for biology, I want you to review the organelles that we talked about. If it wasn't 13, then ignore that. Maybe it was 11 or something. But review the organelles that we discussed and their functions. So I won't test you on all 11. I want that to be clear. All 11 or 13 or whatever. I'll test you on like 5 to 8 or something. But the other thing is, even if you did study all of them, and even if the biology unit was our last one, it's a testing situation. You know, people get nervous and then your mind starts to sort of shut down and you forget things that an hour after the test, oh, that's what a ribosome is, you know? And so I don't want it to be like that. There might be a question about a ribosome, but I'll improve your chances of succeeding in the biology section of the test by not testing you on every single organelle. So you don't have to memorize all of them. I can't tell you which ones you'll be tested on and which ones you don't have to worry about, but if you memorize all of them, you'll probably be okay if you forget a couple of them after that. So, you know, if you forget a couple of them during the test. So you should know the organelles and their functions, and that is kind of it. That's all you really need to know for the biology section. So if you know what the organelles are and you know what they do, then you should be good. In the chemistry unit, there are 2 things that we talked about. I had the review somewhere up here in front of me. Yes. So for the chemistry review, or for the chemistry section, diagrams of atoms, so like Bohr diagrams, is one thing that you'll be tested on. But now the exam is multiple choice, so it's not fair of me to say your whole exam is multiple choice and then ask you to draw, you know, like a nitrogen atom or something. So what I'll do instead is, if you've got your nitrogen atom and, you know, I draw 1, 2, 3, 4, 5, 6, 7, something like that. If I draw a nitrogen atom like that, I have a couple of things that I could do with this question. I could take away the N. So I've drawn all the electrons properly, and then I could ask you, which element is this? You know, which element goes here and what symbol goes here? And you have to decide that. So maybe I could, if I ask for the element and the symbol, I could have one option being nitrogen Ni and another option being nitrogen N, right? So I could change it up like that as well, that the element is the same, but you have to get the symbol right as well. So I could do something like that. The other thing I could do is I could put an N here. So it looks like nitrogen, everything's perfect, but then I move these dots, these innermost electrons, and I put them right there and right there. And then I ask you what's wrong with this diagram, and I give you 4 possibilities of what's wrong. The element name is wrong. There's not enough orbitals. There's too many orbitals. The innermost orbital is empty. You know, like there's different things that I could do that make this wrong, right? I could even add like a third orbital. Whoops. I could even add a third orbital and then like chuck this electron out here. So, all right, like I'm making it look nothing like the original atom, and then ask you, what have I done wrong, or how do I fix it? So that's something I can ask you for diagrams. The other thing I could do is I could say, which one of these is the correct diagram for nitrogen? And I just give you 4 different elements, and I've drawn them all correctly. And you just have to figure out which one is nitrogen. So for that, you should be familiar with the first 10 to 20 elements on the periodic table. Just because if you're counting the electrons, you should know how many electrons nitrogen has. And if you look back at our chemistry notes, there is a pattern when you're looking at the periodic table to knowing how many electrons it should have. And the other way I could do it, so the one way I could do it is saying which one is nitrogen, and I draw carbon, nitrogen, oxygen, and fluorine without writing the symbol. Or I could draw 4 nitrogen atoms with 3 of them being incorrect. That's, you know, the number of electrons in a certain orbital is wrong or something, or I've kind of drawn them all haywire all over the place. That's another thing to remember. I probably won't do this just because I don't think I focused on it as much with the parrots, but if you've got an atom and it's got 8 electrons or close to 8 electrons in this outermost shell, please do not draw them like evenly spaced out, because this is not correct. So don't draw 8 electrons like that. If I gave you something like this and I said, is this correct? The answer for that would be no. There are 8 electrons there, and sure, that might be, you know, that orbital might be able to hold 8 electrons. We've got another one there with its 2 electrons. Also with the 2 electrons, they should be paired up, so don't draw them like this. You should have 1, 2 up here, and then a pair of electrons here, a pair of electrons there, a pair of electrons down there, and a pair of electrons over there. So they should all be paired up if you've got that even number. But you can look back at the chemistry notes for that. I won't penalize you too much if you have 1, 2, 3, 4. Technically, that's improper. You're supposed to go. You're supposed to start by going around in ones and then pair up. So you go 1, 2, 3, 4, 5, for example, right? Or 5, 6. So don't go 1, 2, 3, 4, 5, 6, empty. It should be 1, 2, 3, 4, 5, 6. You just keep going until you've got 2 everywhere, and then you make a new orbital. I won't be too picky on that, and in order to make sure I'm not too picky on that, I'll try not to ask any questions where, you know, I've drawn a diagram incorrectly using that method. I'll use a different way of drawing it incorrectly. Maybe I'll make the orbital squares or something. So the second thing you need to know for chemistry, the first bit is diagrams, those all of that you guys did fine with that when we were studying chemistry. The second thing is bonding. So that's the ionic bonds and the covalent bonds. So that's when, you know, you've got your fluorine and your lithium, let's say, and you draw out both of them and it's all going great. And then I ask you, okay, I've drawn these too close to each other, but you kind of get the point. Yeah, something like that. Okay, this is awful. But basically, I give you this 1, 2, 3, 4, 5, 6, 7, 8, 9, something like that. And then lithium, you got 1, 2, 3, right there. I'm sorry, this is messy. So you've got your atoms, something like that, and then I ask you what happens. Do these two share these electrons, or does the fluorine donate its electron to the lithium, in which case you draw an arrow, or does lithium donate its electron to fluorine? What happens, right? So you need to be able to know the difference between ionic and covalent bonds. I'm sorry that the diagram was a bit messy, but If you're still not sure, the diagram was better the first time I did it, and this is the same live stream as the first time I did it. So afterwards, I will have this posted to YouTube so you guys can refer back to it over the coming week. And if you're not happy with that diagram, then I did the same diagram for the parrots. So that's your chemistry section, the diagrams and the bonding. You need to know when you have an ionic bond, when you have a covalent bond. If I draw it as a diagram and then I say, which one is it? You need to be able to tell me which one it is based on whether the covalent bond, whether you see that bubble with 2 electrons inside for a covalent bond, or whether you see 1 electron being donated to the other atom. So that's the chemistry section. It will be more extensive than the biology section, I think, but less so than geology and astronomy. So speaking of geology, we'll move right on to that right now. So the geology unit, there are 4 things that I can test you on for this. The first is classification of rocks. So this is basically the stuff from the rock cycle, but you don't have to memorize the rock cycle itself. If you can just understand the rock cycle in the sense of you understand how each type of rock forms, then that'll suffice. So if you understand that if a rock of any type melts into magma or lava and then cools and solidifies, you always get the same type of rock as an end product, an igneous rock, right? If you have any type of rock that's eroded and then you get sediment and then it cements all together, you always get the same type of rock. So that's what I want you to understand. To do so, to gain that understanding, it can be beneficial to look at the rock cycle, but you're not going to be tested on the rock cycle itself, okay? So hopefully that makes sense. So review classification of rocks. If you want the rock cycle diagram that was in our notes, because it was all nicely sort of color-coded by what process is happening, and if you can't find it anywhere, send me an email. Anything from the second half of chemistry onwards, I have the PowerPoint lessons that we actually did in class. So I have the entire geology, physics, and astronomy units. I have the entire geology and physics units in PowerPoints. All of the astronomy lessons are on YouTube, and half of chemistry is with me as well. The rest of it was handwritten stuff. We did it in class, so I don't have as comprehensive review of that material. But for geology, if you want like the diagrams and the relative dating stuff, let me know. I have all of it. So first was classification of rocks. Second was plate tectonics. So you should understand a little bit about like the theory of it, but mostly what I'm getting at with plate tectonics is the different types of plate boundaries. So convergent, divergent, and transform faults. So what they are, so it kind of in theory of like, are the plates moving together? Are they moving apart? Are they moving side by side? But then also in terms of practice, that if I gave you an example that you've got the Indian subcontinent and then Asia, and then there's a mountain range in the middle, which type of plate boundary is it? You need to be able to figure out, well, there's only one type of plate boundary that's really known for making mountains, right? And so that will hopefully kind of help. Well, I guess, I mean, I would give you a bit more information, but so like I'll give you like a real world scenario that you've got like a trench, and you've got this other information about it, that there's a mountain here, and then you see a section of the crust dipping down. What type of boundary must it be, or what is the name for which type of boundary includes subduction, a plate going down into the mantle of the earth? So you need to know kind of how the different plate boundaries work, not just their names. All right. And the next thing is geologic time. So this is like all the eons and eras and stuff. So there are a few things I could ask for geologic time. I could ask you things like, what era are we living in? And give you a few options. The asteroid impact that killed the dinosaurs was the dividing line between which two eras? And then I give you 4 pairs of options, you know, Mesozoic and Cenozoic. Or in the reverse order, Cenozoic and Mesozoic, I could give you that as well. But I could also say things like order these durations of geologic time in order from longest to shortest, and I give you an era, a super eon, an age, and a period, or something. And then I've rewritten them in 4 different orders, with one of them ordering them from longest to shortest. So you should know the order, the sort of the scale of geologic time. What's bigger? What's a bigger unit of time, and what's a subdivision of that unit of time? Yeah. So, and I could also ask you for geologic time. I won't do this too much. You'll see this more in astronomy when we get there in a sec. But I could have you order some simpler stuff. So not like the nitty gritty ages and stuff, but eras or eons or something. I could have you order them in chronological order. So which came first, second, third, fourth, or just which one came earliest to which one is the most recent or the current one. So I could ask you a few different things for geologic time. And the next thing is relative dating. And this is the last thing for geology. Relative dating. So relative dating, we talked about 7 or 8 different techniques. So I could ask you questions that, like, if I just write out in words something about a rock that's cracked or something, what technique have we used? What technique of relative dating have we used if a rock was found with a crack running through it and the rock below it, or something like that, a fracture running through it? But I could also ask you things like, I give you a diagram and I say rock A, rock B, rock C. Scientists determined that rock A is the oldest. How? So the question is how, and you have to tell me which principle of relative dating have we used to deduce that rock A is older than rock C. So something like that. Okay. Once again, this was a case where we talked about more than what I tested you on. So even though we talked about 7 or 8 different techniques, I probably won't test you on that many. I'll test you probably somewhere between 3 and 5-ish, but possibly to the lower end, just because all of this needs to fit into one class's test. If you're doing all the questions at a steady rate, you need to be answering more than 1 question per minute. So I don't want to make it too difficult. So that's geology. Physics, we talked about a few different things, but I'm only really going to test you on a couple of them, and a couple of the, I think, simpler things that we talked about. And that's because you guys did well. So this is hopefully going to be more of a mark booster than a tester. So the first thing is Newton's laws. So you should know what they are. And once again, just like we had with geology and plate tectonics, know what they are, but also know how to recognize them. So it's one thing to know that an object in motion will remain in motion until, an object in motion will maintain its constant velocity, blah, blah, blah. It's one thing to know that definition. It's another thing for me to say a hockey puck is sliding across an ice rink at a constant speed or at a constant velocity until it hits the wall at the other end of the rink. Which law is at play? So you need to be able to recognize, oh, it's an object in motion traveling at constant velocity. I might not specify the constant velocity as a hockey puck is sliding on the ice and then it hits the wall, right? If I say it bounces off the wall, then you could have a case for the third law as well. But if I'm just saying, it's sliding and it doesn't stop until it hits something, then you need to be able to recognize what I'm talking about, which law I'm getting at. All right, so you need to know what they are and how to recognize them. And then the second thing was energy. It'll be more of a theoretical side of energy, less math. So it'll be more of things like, if I drop an object from this height and it falls all the way to the ground, when I let go of it, does it have all gravitational potential energy, all kinetic energy, some of both? When it's falling, does it have all gravitational, all kinetic, some of both? When it hits the ground, does it have all gravitational, all kinetic, some of both? So things like that. So I won't necessarily ask you to do the math that if I drop a marker from a height of 1 meter in a vacuum on the surface of the Earth, 1 meter above the surface of the Earth, what is the speed when it reaches the ground? I don't have to ask you questions like that. It'll be more of the theoretical side of if a ball is rolling down a hill and it's getting faster and faster, which types of energy does it have? Gravitational, kinetic, thermal, whatever, and I list a bunch of different types of energy, and I'll say, which one does it not have? And you have to find the one that it doesn't have, things like that. So it'll be more of the theoretical side. There might be a little bit on the math side, but because your test is going to be the exact same as the parrots, and I didn't do as much math, I didn't do as much of the calculation side of it with the parrots, there won't be a lot of math in the physics section for this. All right, now the last unit we talked about was astronomy. So the first thing that you need to know is facts about the planets. So what I mean by that is, if you want, you can, it's less of the interesting facts from our presentations and more of things like just familiarity with the solar system. So 2 things that you absolutely should know: the order of the planets going from nearest to the sun all the way out to farthest from the sun. If you know it that way, you know it the other way. So you know the order of the planets in terms of distance, and also know the order of planets in terms of size. So know them in order from biggest to smallest, or smallest to biggest. Because what I could do is I could ask you questions like, what's the biggest planet in our solar system? But I could also say, what's the 4th biggest planet in our solar system, right? I could say, order these planets in order from largest to smallest. And I go Saturn, Mars, Venus, Neptune. And you need to know. You need to know the order of all of them, right? Not just their sizes. But you won't need to know things like the radius of Jupiter is 69,911 kilometers or anything like that. I'm not going to say which one of these is the correct value for the diameter of Earth, and then I give you 4 numbers in the thousands. I'm not going to ask something like that. But I will say, which is biggest out of these 4 objects. And I say Earth, the Moon, Mars, and the Sun, or something, right? It's a little bit too easy, but you get the idea. So you should know facts about the planets, maybe a unique fact about each of them. Like an easy example would be the planet with the brightest rings is blank, and you have 4 options, and you need to figure out which one it is. But I could also do more obscure ones with like the planet that rotates on its side, the planet with an atmospheric pressure 92 times that of Earth, or the hottest planet in the solar system is, the coldest atmosphere in the solar system is, the planet with a great red spot, a storm the size of Earth, is blank. And you should know these sort of facts about each one. The Curiosity rover is on the planet blank, right? You should know these kinds of things. The second thing, so we got planets, but then we also got stars. You should know the life cycle of a star, including what happens when it dies. So you should know how stars form, the different types of stars that you might get, like the low mass ones and the supermassive ones. And you should know when they're approaching the end of their lives, what happens, the red giant and red supergiant stuff, kind of, but I won't test you too much on that. But it's more of when they die, when their cores collapse, that kind of thing. When their cores collapse, the word supernova, these kinds of things you should be aware of. I could ask you a question: when the core of a massive star is collapsing, which of these is not happening? And then I tell you 3 things that are true. The core is being compressed, or whatever. Fusion is taking place through pressure. And I could give you all these different things that are or are not happening, and then ask you to pick out the one that just that doesn't fit with the rest of them, right? So you should know the life cycle of stars, the death of stars, the stellar remnants that you get, so white dwarfs, neutron stars, black holes. You just know what they are. And is there anything more for stars? Not really. I mean, I just know what those 3 things are. There are other types of stellar remnants that you can get, so I don't want to make it too complicated. But I know that you guys did enjoy most of the astronomy unit, so maybe I'll put a little bit more emphasis on that. Then the next thing is the moon, phases of the moon specifically. So you should know specifically the one video where we talked about the different phases of the moon. You don't need to know them inside and out. You should just know, if I draw a crescent moon on the board, you should know that it's called a crescent moon. If I draw a gibbous, you should know that it's a gibbous. I will not be particular on waxing crescent versus waning crescent because it's just a difference of side. And same for waxing gibbous and waning gibbous, and maybe even for first quarter and last quarter. But I could ask you things like, what phase is this? And I draw a specific phase on the page. I could also do something like, which of these phases comes soonest after a new moon? And then I give you waxing gibbous, full moon, last quarter, and waning crescent or something. And you have to know either, which one comes after the new moon or put them in order. Something like that. Put them in an order, starting from new moon to new moon. Put them in order. Which one comes first, second, third, fourth, things like that. So specifically the phases of the moon. And then the last thing is exoplanets. So you should know what they are. You should know sort of the different types. We talked about hot Jupiters. We talked about super Earths very briefly. It'll just be like, name a type of exoplanet, and I'll give you a real name and 3 fake names or something. But it'll be something like that. And you should know a little bit about the techniques that are used to detect exoplanets. So I might give you a little bit of a paragraph, a little bit of a blurb about what they are so that you remember what they are. But then the question would be something like, why does transit photometry favor exoplanets with small orbits? Something like that, or large planets, things like that. So I'll give you a blurb on, this is what transit photometry is. But then the question is, why does this not work for every type of planet? Okay, so it is something we talked about. You can go back into the astronomy videos. That's the advantage you guys have with astronomy, is that the entire unit can be watched as many times as you can fit it in between now and Monday, if you so choose. So the greatest focus on the exam will probably be astronomy, partly because you have all the information readily available. 2, we never had a test, and 3, I get carried away with things that I like. It's just about 11:20 now, so if you guys have any questions, have someone let me know. Otherwise, you can send me an email. I've been having some technology issues transferring email things over between devices. But if you sent me an email and didn't get a reply, resend the email. If you have any other questions, get in touch with me somehow. And if you have any questions about math as well, let me know. Otherwise, you guys are good to go for your last class, which is English, I think, maybe something like that. I don't know. But yeah, you guys are good to go for your last class, and I will be uploading this entire review session with the parrots bit and the flamingos bit all in one, so that you guys can access that anytime. All right, so that is it. I will stay on for a few more minutes in case you guys have any questions, but after that, you guys are good to go, and I will post this as soon as I end the stream. So you guys are hopefully ready now for the test. If you have any questions, I will be happy to answer them. They can be as general or as specific as you like. One of the questions from the parrots class is that, is the test going to be only multiple choice? And yes, it is. It's 50 multiple choice questions, and that's it. There will be diagrams and stuff in there, but you don't have to draw any diagrams. You have to sit there and bubble in 50 answers to 50 multiple choice questions, and that's it, and then you're done. It will also only be one class. Your math exam is 2 classes, but your science exam is just the one. And I will try to have them all marked in time for the very last science class on Wednesday. All right, so that is it. You guys are good to go for your class. If you haven't already, I will stay here for any questions and then end the stream. All right, looks like no questions, so I will end this here. All the best.